Taking a massive artificial intelligence and training it on curated data is how you turn a generic text predictor into a highly specialized, useful tool. This process, called fine-tuning, is the exact mechanism that transforms a raw algorithm into a refined assistant like ChatGPT. But fine-tuning a state-of-the-art 65 billion parameter model requires more than 780 gigabytes of GPU memory. That requirement effectively locks independent developers out. It keeps the cutting edge of AI development strictly in the hands of massive corporations who can afford to build and run billion-dollar server farms. A research team from the University of Washington recently bypassed that hardware requirement. They found a way to take that 780 gigabyte footprint and compress it until it fits onto a single 48 gigabyte consumer GPU. They achieved this compression in just 24 hours of training, while attempting to match the results of systems that use 10 times more memory. To pull this off, the researchers engineered 3 distinct memory optimization techniques. They managed to shift the bottleneck of AI development away from raw physical hardware and firmly into the realm of clever software engineering. This diagram outlines the baseline. The center column shows LoRa freezing the 16-bit base model to train tiny adapters. But a frozen 65 billion parameter model still consumes hundreds of gigabytes. To fit, the base model on the right is quantized from 16-bit down to 4-bit. Historically, standard 4-bit quantization damages the neural network. During compression, the algorithm routinely chops off extreme data values, known as outliers, effectively lobotomizing the model. The first optimization, 4-bit normal float, relies on a quirk. Normal network weights form a standard bell curve. It uses this curve to calculate optimal storage bins, clustering them tightly at the center and stretching them wide at the edges to perfectly capture extreme outliers. NF4 acts as a perfectly tailored filter. It drops the total memory footprint dramatically while preserving the exact intelligence of the original model. Even with NF4 compression, the mathematical constants used to calculate that 4-bit translation still take up space. On a 65 billion parameter model, those constants alone consume about 3 gigabytes of memory. To solve this, the researchers introduced double quantization. They run a second 8-bit compression pass on the constants themselves, scraping away every possible fraction of a gigabyte. The model now fits on a 48 gigabyte card, but training creates unpredictable memory spikes that normally crash the GPU. Paged optimizers act as a pressure valve, safely overflowing excess data into standard CPU RAM until the spike subsides. The combination of NF4, its double quantization, and paged optimizers solves the hardware barrier directly. It allows a single desktop computer to process a workload that previously required an entire server rack. A 780 gigabyte training requirement was successfully squeezed into less than 48 gigabytes, keeping the massive 65 billion parameter model perfectly intact. The scale of this compression is even more extreme on smaller architectures. Applying this method to a 7 billion parameter model shrinks the required memory footprint down to just 5 gigabytes. That is small enough to deploy a highly capable AI directly onto an everyday smartphone. To prove this architecture worked outside of theory, the research team used it to train their own custom family of models called Guanaco. When put to the test on the Vicuna benchmark, the 65 billion parameter Guanaco model scored a 99.3%. It performed almost completely on par with ChatGPT. It reached that parity while being trained from top to bottom in exactly 24 hours, running entirely on a single consumer-grade graphics card. The QLORA architecture proves that the future of artificial intelligence development will not exclusively belong to massive corporations with endless server farms. A brilliant, scrappy software optimization can put that exact same power directly into the hands of everyday developers.